Three global experts joined forces and combined their competence. They became a world leader in chlor-alkali electrolysis, producing raw materials for industrial progress. Our unique expertise in developing, constructing, operating, maintaining, and advancing high-efficiency electrolysis plants has allowed us to enter a new era. We've become thyssenkrupp nucera, a leading global electrolysis technology provider. Today, we build on our heritage, our expertise, and our strong track record to scale up alkaline water electrolysis and address one of the biggest challenges of our time: to reduce CO2 on a large scale. By enabling industry transformation with green hydrogen production at commercial scale. Based on our core competence, we have developed two strong portfolio elements that create synergies. Growing, learning, and constantly improving our leading technologies to strive for the best. The future offers an opportunity to shape something that matters. Innovative solutions for industrial progress and green value chains.
Electrodes will play a primary role in delivering sustainable solutions for the environment in the next years. It is a must to have resistant and efficient electrodes. This is where the Nora's knowledge and experience makes a difference.
Wherever you look for great innovation in smartphones, PCs, tablets, and other electronic products, you will find Nora's electrodes. We at Nora are strongly focused in making our manufacturing process more sustainable. We can make differences in decarbonization.
Our electrodes for the chlorine and caustic soda industry have superior performance in terms of energy consumption, efficiency, and high product life expectancy. I am lucky to work in a company dedicated to making people feel that they are the most important resource. With its global presence, Nora promotes diversity, equity, and inclusion.
We believe our company will play a pivotal role in a future of full electrification, both direct or through green hydrogen.
It is decisive to have the proper technology for green hydrogen production. Nora is ready today, and it will be readier soon, thanks to its production capacity expansion plans.
Only recently have industry experts, academics, and government leaders come to the realization that it is just not possible to electrify everything. This is where green hydrogen comes in. And thanks to the world-class electrodes here at Nora, we are serving as the launch pad for the hydrogen revolution.
Our water technologies are defined by key innovation proven by time. One of the hardest challenges we need to face is providing cost-effective water treatment solutions to remote areas, so we can continue bringing positive changes to our world.
In our world today, many regions face increasing challenges of water scarcity. Nora delivers clean water through our robust filtration technologies, which are continuously upgraded. There's still much work to do in this field, and Nora is a fundamental player in this mission.
As an expert in this technology for 100 years, Nora has been and continues to be instrumental in making chlorine available and cost-effective in the quantities needed for water treatment. The wide variety of challenges, the wonderful people you meet, and the constant focus on human health and environmental stewardship made me realize it was one of the best, if not the best, business to be in for me. I hope you've enjoyed getting to know my colleagues and me a little more this year. Stay tuned for more Decode in 2024.
We know time is running. We need solutions ready to use on a large scale. We have to think big. Alkaline water electrolysis provides the necessary big scale already today, is reliable and safe to run. We use and advance this proven technology to shape a new energy age. Long-standing know-how and expertise provide high efficiency and proven quality, sustainability with highly durable and long-life cells, full service solutions from a single source, and the passion to improve and innovate. We combine about 300 high-efficiency cells into one powerful unit. Scalar, a standardized modular solution that can be scaled up row by row. We ramp up our capacity day by day, together with partners as a driving force. We think, we act, and we walk ahead. Who we are? thyssenkrupp, nucera. We shape the new era.
Good morning. Ooh, too loud. Sorry. Good morning and welcome. Can I please all ask you to take a seat so that we can start on time, because we also have a live stream and do not want to have people wait remotely for too long.
Good morning, everyone, and welcome to our joint open house. We are so thrilled to have you here with us today, and I'm sure that together with our colleagues, we will do our best to make you feel comfortable and to enjoy the next few hours together. My name is Rona Lombardo. I'm the Marketing and Communication Manager of Industria De Nora, and together with me on stage today to guide you through the event, there is Katharina Imur, Head of Communication and ESG for thyssenkrupp nucera.
Thank you so much, Rona. Also, very warm welcome from my side. Very happy to guide you through the next 2 hours together. Also having a brief look into the camera, very warm welcome. Thank you so much for joining remotely as well. And having said that, I think we can start.
Yes, so just before starting, Katharina, I would just like to invite on stage the Chief Regional Officer of De Nora Rodenbach, Mr. Robert Scannell, since we need to explain you the safety measures.
That doesn't work. Okay, welcome welcome from my side as well. My name is Robert Scannell, and my pleasure to welcome you to De Nora Deutschland in Rodenbach. And my duty and my personal conviction is that I have to make sure you and everybody else leaves here safely today. It is very high up in our agenda, if not on the very top. Some of the basic rules you will probably know from every industrial plant that you have visited. Most important one is no smoking, no drinking outside, but there's nothing here to drink anyway, so you can come back here. Please be careful of moving objects. You will be led through the tour, which I'll describe in a moment, by tour guides, both in front and back, so as to allow us to not use safety shoes for yourselves. But please stick to the route, stick to the people, and you get more information from the guide, the tour guide anyway, that will be joining you. In the case of an emergency, which will be with an alarm, please exit the plant the way you came in, the main entrance. Your assembly point is in the car park. When you exit the company, turn right, and then there's a designated assembly point for yourselves. This is to make sure that we have everybody safely outside the premises. The other, let's say, golden rules when we go into the production is please do not touch anything, both from the point of view of cleanliness and yourself, but also we have a lot of sharp metal pieces in the manufacturing, and also chemicals. We will give you safety glasses during the tour. They will be distributed. These are precautionary in the coating section and not mandatory in the other areas. So I finished the very short introduction on safety. If you have any questions concerning specific areas, it's quite small chart here. You see the premises has almost 40,000 square meters and quite complex and integrated. And during the tour, I will explain in detail, and the tour guides will explain in detail the construction, layout, and optimization of the plant. Please stick to the group. And also, I have one thing that I noticed earlier: smoking is not allowed, including e-cigarettes on the premises. There are smoking areas just outside the plant if you wish to smoke. Okay, thank you very much.
Thank you, Robert.
Thank you so much. Well, Werner and Paolo, can I please both ask you on stage right now, because we will start with the CEO presentations, first by Paolo De La Ca, CEO of Industrie de Nora, and then followed by Werner Ponikwar, CEO of thyssenkrupp nucera.
Welcome, good morning everybody. A warm welcome to our joint open house. I say warm because if you were coming here yesterday night, it was not so warm. So thanks God the heating system had been working overnight. Thank you for being here. Sorry for this cozy tent. We are a factory here, so we don't have fancy spaces to have these big events, so we had to build this temporarily. But I think it's comfortable enough for you to resist a couple of hours to listen to us. So we start the intro about De Nora, and then Werner will take over about nucera. You can see in the screen, this is a snapshot of our group, 100 years of history starting from last year. We celebrated 1923, 2023. Our company is made by three pillars, three business units. The electrodes, which is our historical, very strong part where we started from, and where, of course, we also serve nucera from there. A natural evolution for us has been to evolve into energy transition, because again, green hydrogen is an electrochemical product, so that's helped us to play in advance to anybody else, together with nucera, and establish the best available technology in the market. We do have also water technologies for the water treatment that we started a little bit later than the rest of the business. We are all over the world. For us, proximity to customers is essential, because we provide a lot of service to the install base we created over 1 century. So we have, as you can see, 24 operating companies, out of which 15 manufacturing or assembly when we talk about water treatment systems around the world. We exceeded 2,000 employees last year, and we ended up the year with 856 million euro in revenues. We went public, as you know, in 2022. Of course, the backbone of our company is continuous research. So we have 5 research centers, 2 in Japan, 1 in Italy, and 2 in the United States. And of course, we keep innovating also through our intellectual property. So only in the last year, we filed for 17 new patents. So ending up at 281 patent families and almost 3,000 territorial extensions to protect the IP worldwide. What we do, to enter a bit more in details, simple in our wording. So in the electrode technology, we do electrodes. We do electrodes for many different industrial applications. And of course, as we are here today, we also are the manufacturing company for the cells of nucera electrolyzers in chlor-alkali. And of course, on the other side, for nucera electrolyzer in the hydrogen business. Water is very connected to the electrode business, meaning that when we are talking about electrochlorination to treat the water, it means that that's the connecting part between our systems to treat the water and our electrodes. In every system we manufacture, there is the Nora electrode to enhance the performances of the water treatment. Of course, to stay in water, you cannot only have electrochlorination, you need to have a much wider range of technologies, and that's why we have the widest range of disinfection and filtration technologies to serve many different kinds of water worldwide. Our life, as I said, is very much based on service, thanks to the installed base that has been created. So for each of these business, service is essential. In hydrogen, not yet, because we just started. So we will see the revenues in service picking up over the next years when the installed base will be created. You see also the breakdown. The new baby is energy transition. Nevertheless, it was in 2023 already 12%, which is quite impressive, considering that it's a just-born industry. And again, you see the split between new equipment and revenues. Actually, as I said many times to most of you, our service portion is higher than that. But as like in pools business, whatever we sell is considered new because our customers are not disclosing how much goes to service, how much goes to new equipment. Actually, we know that part of the new goes into service as well. So the percentage is actually higher. These are the 4 pillars of the Nora strategy. So growth and market positioning, product leadership, manufacturing expansion, and organization development. These are the 4 key pillars that are driving the strategy of the group over the next years. Growth and market positioning, of course, we count and we are working hard to continuously grow in energy transition and in water as well. We are market leaders, so we protect and we continuously invest in our product leadership through a never-ending research and development to keep the edge towards anybody else, and of course, the service, which is driving our revenues and also our profits. Manufacturing expansion, we are a factory, you will see here, and you will see here works in progress, meaning that every time our partners give us an order, we need to fulfill it. We need to fulfill it as they expect in terms of timing, costing, and whatever. So for us, the growth is expanding our manufacturing footprint, not only here, worldwide, because we serve a global business, so we cannot focus our expansion only in one place. And of course, because we produce, our continuous improvement approach in executing our work is essential and is our mantra on a daily basis. Last but not least, the organizational development, meaning that we are a business made of people. So the people strategy, the people development is a backbone of our organization, together with all the infrastructure continuous evolution, from digitalization to now the ESG plan that we just launched, to cybersecurity, to whatever is involving the internal organization of our group. ESG. we just got the approval in December 2023 from our board of the new ESG plan up to 2030. It's a comprehensive plan that we have launched, and we are very determined in that. I will maybe leave the word to my colleague Chiara Locati, who is responsible for IR, but also for ESG, that she can go a little bit deeper in this couple of charts describing you what we are doing and what we are going to do in the ESG.
Thank you, Paolo. Yes, it's true. In December 2023, we launched our ESG strategy and action plan to 2030. And our strategy is that, as well as we are leader in the main industries in which we operate, we are committed to become leader in some specific space of the sustainability, which are material for us. We provide clean, sustainable, innovative technological solutions that our colleagues are going to explain in a few minutes to you. And we do that promoting circular economy, and we've engaged people that are eager to make the difference. So we want to become leader and able to shape the industry in green innovation, circular economy, while boosting our climate action profile. In that slide, you can find the 4 pillars of our ESG strategy. The first is green innovation. The main initiatives in green innovation are the introduction of a circular design guidance in our R&D processes, and we are near to achieve this target. Then, the most important initiatives we are working on is the realization of a sustainability scorecard for our product, based on the LCA methodology, able to assess the impact of our products in terms of climate action, carbon footprint, biodiversity, water, circularity. We target to assess all our products by 2030 and all our new products by 2027. Then, of course, our activities related to R&D are strongly committed to reduce the use of some key raw materials, such as noble metal, and I have to say that we have a target of reduce them by 4% by 2026, including not only the energy transition products, but also products in pools and the chlor-alkali electrodes. For what concerns climate action, we target to halve our Scope 1 and Scope 2 emission in line with the 2030 agenda, and to have also our Scope 3 emission intensity for the same date. We want to improve the use of renewable energies at our plants, and we have a target to reach 100% of renewable energy by 2030 and 40% by 2026. And we are already working on that. You have to consider that here in Rodenbach we have installed a solar plant on our roof, yeah, and they are connected and working in this moment. So it's a very important achievement for us. For what concerns circular economy, you have to consider that our products are circular by design. They are circular in their DNA because they are designed to have a second life. In fact, the reuse of our electrodes and the noble metal that they contain is something that's related to our day-by-day activity and aftermarket services. So we are committed in that, but we also are committed in reducing our waste and improving the use of our packaging, which are made in wood. We want to be able to reach 80% of deforestation-free wood in our packagings by 2030, and we want to be able to reuse our wood packages for a rate of 40% by 2026. So very, let me say, challenging targets on which we are working and on which we are really committed on. Again, people is another important chapter within our sustainability strategy. People are at the center of our company as a strategic asset, and we are committed to take care of their wellness, also in terms of mental well-being, not only health and safety, and considering that we are a group that operate in 4 different continents, for us, inclusion is something that is key. And we are committed, of course, also on the diversity, equity, and inclusion topics. Last but not least, local community and supply chain. For what concerns local communities, we have a number of initiatives related to the support of the territories in which we operate. For what concerns supply chain, we are committed to build a sustainable supply chain, being able to score and assess our supplier in a rate of 50% by 2030. And we will start also with the audit of our suppliers in 2025. Very, very quickly, few target we achieved this year. 22% is our vitality index, which means the percentage of revenues coming from new products, which is a great achievement. The same data last year was 14. The big increase is due to the energy transition business unit. We achieved 17 new patents. 66 of our R&D expenses are related to energy transition. And we have been able in the last 2 years to reduce the use of noble metal by 5% in our coating formulation. In climate action, I will just mention the fact that at the moment, we have installed 3.1 gigawatt hour of capacity to produce renewable energies in Italy, Germany, and Brazil. In Brazil, our plant will fulfill all the energy needs with renewable energy. For what concerns people, we achieved a great place to work last year in Italy, and in governance, we carry out a number of new policy we needed to have, and maybe an important thing to say is that our CEO and top managers' variable remuneration is linked to the ESG target, testifying how sustainability is key for us. I thank you for your attention, and now I give again the floor to Paolo.
Thank you, Chiara. All right, so this is my last chart before giving the floor to Werner. The Nora and nucera have a fantastic history behind, and that's in this chart we try to represent how interesting has been this journey. So in the 60s, in the 70s, there were competitors playing one against the other in the chlor-alkali plant business. One was Ude. One was a little bit later this company belonging to Mitsui in Japan, Chlorine Engineers Corporation. Then at a certain point, and the Nora was also competing in the plant business at the time. So at a certain point, the Nora and Ude, thyssenkrupp Ude, they sit together and they decided to unify, to merge their strengths at the European level at least, to fight better against the Japanese. So they created a 50-50 JV in 2001 called Ude Nora. That was very successful and started playing on a global level worldwide. But of course, there were still these Japanese enemies fighting also globally. The Nora at the same time had a joint venture with Mitsui called Permelec Electrode that was making electrodes with them. And when we approached them to stimulate a discussion and trying to buy this 50% belonging to the Nora of the JV, we found out that actually the whole electrochemical platform of Mitsui could become on sale. So we have been pushing hard to avoid that this player could fall in the wrong hands. And we managed in 2011 to buy not only our JV, but also to buy Chlorine Engineers Corporation from Mitsui. It was a long journey, very tough. First we bought the majority, then we bought 100%, 1.5 years later. But the day after we did this acquisition, we started talking with thyssenkrupp and saying, okay, now we bought a competitor. What shall we do? And we initiated a very long, and I would say also complicated discussion and journey that brought us to form the new joint venture with them. A totally different joint venture because everyone contributed into that new platform, whatever was related to the chlor-alkali plant business. So Ude gave a piece, we gave Chlorine Engineers, Ude Nora was of course contributed over there to form the strongest platform in the world making this kind of plants in chlor-alkali. But it's curious to remember that already in 2012, while drafting our joint venture agreement, we already wrote that we would have focused on green hydrogen plants. So it's a phenomenal story. And then we went through antitrust filing, so it took a few years, and then we ended up 1st of April 2015, we launched what we called originally thyssenkrupp Ude Chlorine Engineers. Complicated name to respect these two very, very strong and powerful brands that were so successful worldwide. And then when we were convinced enough that it was the time to change the name, we went to thyssenkrupp nucera in 2012. And last but not least, almost 1 year ago, also nucera went public at the Frankfurt Stock Exchange. So I think that this is really an incredible story of two partners that found the best win-win solution to help each other and to become so strong and gaining a very, I would say, incredible leadership position worldwide. So now I leave it to my friend Werner to tell you much more about that.
Thank you.
You have, okay.
I do have a microphone. Can you hear me now? Okay. Well, and here we are, thyssenkrupp nucera, a world leader in electrolysis technology. We can both look back at a exciting and very, very long history. So we are not a startup anymore like many others in our industry. We are really a mature, grown-up business with more than 600 projects that we have already delivered in an industrial scale in terms of electrolysis, more than 10 gigawatts of electrolysis capacity already installed, large and long history in the field of chlor-alkali. Chlor-alkali being really our heritage and a field where we jointly, also with, continuous innovation, continuous R&D, continuous improvements of technology, achieved an outstanding market share of roughly 50%. So our technology in the field of chlor-alkali is used around the planet, and is preferred by many industrial customers still today. And of course, that also gave us the opportunity to really, optimize and mature our technology to the largest extent. So it was for us a very logic and easy step to take everything from the chlor-alkali design and technology and copy it to a new system. The new system is an alkaline water electrolyzer that we have developed and commercialized, and we are selling to customers around the world since a couple of years only. But if you look at actually the order backlog that we have created also already with that, it's already double of what we have typically in the chlor-alkali field. So it really means this is a very well accepted technology, a very well accepted electrolyzer system already in the market, and we have many customers out there trusting in our ability to design such a technology and also to deliver such a technology. And that's, I think, another big advantage that we bring to the table. We are used to building
industrial scale plants. We can do that, we have proven that actually, and this is actually also why people are trusting in us. Of course, the IPO was at the end only a logic consequence. We knew with green hydrogen, with alkaline water, we are entering a new industry, which with a tremendous potential and with a huge growth. And of course, we were also clear we need to have the financial muscle and a strong balance sheet to really grow also in such a fast-paced and also still very volatile environment. And I think that is something that we have achieved with our successful IPO. We have very much enriched our balance sheet with that, and we are now well prepared to deliver our growth story. Why is it a growth story? Because we are active in a market which is almost hyperscaling in the meantime, where actually we all know that to fight climate change, green hydrogen is and needs to play an important and key role in the energy transition. We need to transform our energy systems away from fossil fuels and burning that stuff actually and producing and polluting our environment with tons and tons and gigatons of CO2 to an energy system actually that does not emit any CO2 anymore. Which means, of course, we need to establish a lot of renewable energy, but that will not be enough. There are some industries that cannot be electrified. And of course, there is also an existing demand of hydrogen as a process gas, as a molecule in the chemical industry, in refineries, etc. Actually, that also is currently produced via steam reforming, also using natural gas, so it's also producing a lot of CO2. All of that needs to change, and all of that is really providing a tremendous potential for green hydrogen being produced via renewable energies, and with that as an emission-free green energy carrier. And if you look at just that chart, it demonstrates that the International Energy Agency is currently expecting for the year 2050 300 million tons of green hydrogen to be required to reach net zero at 2050. And that is already including that there will be also a portion of blue hydrogen and so on and so forth. But 300 million tons of green hydrogen would be required. Today, and you see that right now, it's only 0.1 million ton that is currently produced globally. So we need to increase 3,000-fold in the next 26 years. And to translate it into more tangible things, we are an electrolyzer company, so for us it's electrolyzers. That would mean that in 2050 we would have to have 3,000 gigawatts of electrolyzer capacity being up and running and producing hydrogen every day. Today, we are a bit above 1 gigawatt. So also that is a relation which shows you how big that potential is. And it certainly would mean that over the next 26 years, we would have to install globally 115 gigawatts of electrolyzer capacity every year, including this year, which is quite a challenge, which is quite an ambition, and it will be, I would believe, also quite a challenge to achieve that, but it shows how large that gap is and how huge that potential is actually where we can play, and we are playing already a significant and very important role. And we see that also reflected already in our own business. We are tracking and working on a project pipeline which is good for more than 60 gigawatts already. More than 60 gigawatts of projects which we believe they have a good chance to be realized within the next years. And out of those 60 gigawatts, 19 gigawatts, a bit more than 19 gigawatts, we are actively pursuing. We are working with clients to develop those projects already. And we believe that those 19 gigawatts, I would say 2/3 of that can be realized in the next 18 months and will be signed. So you see already right now that this is quite a huge growth path in front of us and the growth potential. But we came already a long way. In this short period of time of a couple of years, we were able to already contract more than 3 gigawatts of electrolyzer capacities. So these are the projects that we are currently working on in different phases, in different parts of the world, as you see here on the map. Of course, the largest facility in the world that will be up and running in 26 is NEOM in Saudi Arabia, with more than 2 gigawatts of electrolyzer capacity being installed. I can tell you, I've been there just 2 or 3 weeks ago visiting the site. These are 5 big cell houses where actually the electrolyzers will be placed. Every of those cell houses larger than a football field. So in total, 110 of our 20 megawatt scale modules will be placed there and will be erected. First modules are already on site. We are unpacking the modules. We are starting to erect. So the first subskits are already on the foundations. So we are now moving. This is really moving now, also according to plan. There's also other big projects that we are running. H2 Green Steel in Sweden, more than 700 megawatt. But also Shell in Rotterdam, 200 megawatt, and I think we will see also Shell later on talking about that project as well. So more than 3 gigawatts we are currently working on, a big pipeline in front of us. That certainly also means that we need to grow our capacities, we need to grow our supply chains. We have currently a bit more than 1.5 gigawatts of annual manufacturing capacity, not only in terms of cells, here I believe we are even above that, but also really in terms of real electrolyzers. So this is an annual output that we can generate in terms of electrolyzers to support the existing contracts, but also the new contracts that we're currently working on. All of that wouldn't be possible with having a strong global footprint and I would say a highly engaged and skilled and motivated global team. And this is also an heritage that we're bringing with us. We are already a globally active company. You see that here on the map. We are present across the globe with our offices and our activities, and we're still adding, and we have to add to build up our footprint, to build up our teams, because at the end, basically, all that capacity is nice, but if we don't have the people to really deliver the projects, deliver the systems, it's worth nothing. We have just last year found a new office in Mumbai, in India. Also, that has a history. We were working out of India already in the times where we were part of UDE. We have even trained a lot of engineers there on our systems, on our technologies, and we were just carving those out and bringing them actually into our company as a nucleus to grow from, as an expert pool actually that we are now heavily expanding. So we have started with 30 employees. In the meantime, we are arrived already, I think, at 50 roughly, and of course we have plans to further expand that. That's certainly a part of our strategy. You see that as well in Houston and Texas. We have also said that we're gonna initially focus on Europe and in the US in terms of our growth. We need to be focused. You cannot do everything at the same time with a always limited amount of people available to really drive your projects. And of course, you see here as well, you know, this has started as a small service and sales office in Houston with 15 employees a couple of years ago, and has now grown already in an organization of more than 50 employees. By the end of the year, we're expecting it to be over 100 employees. So we have to grow at a very high speed, also our organization, to ensure that we will be able to also deliver on our promises on the projects that we are driving. And that's actually, of course, part of our strategy. We believe we can and we will have to maximize our growth. What does that mean? It basically means we believe that the market pull out there is so huge that this will not determine our growth rate. Our growth rate will be determined by our internal ability to expand our capacities, to enlarge our supply chains, and to build up an organization that is able to really deliver all of that. That's what we mean with maximizing our growth. And this is why we are focused very much on building up capacities, getting talents onto our platforms globally, expanding our footprint, and so on and so forth. At the same time, we are very well aware of, hydrogen will only be established as a competitive source of energy if it is affordable. And part of that affordability is certainly also that we need to provide systems which are cost effective. So we need to bring down the costs. This is why we are investing heavily in serial manufacturing, in automation of our systems, to also finally enhance and maintain profitability in our company. We have decided for our alkaline water electrolysis to take a different approach, and you will see that actually when the two gentlemen here, our technology monsters, I'd say, with decades of experience, actually will talk about that. We have decided for the alkaline water electrolysis to provide only one fully standardized module. And we say module because it is really modularized, and you will see that actually, which makes it easy to be reassembled and to be transported. This is the only way to bring down the cost, because it's like in the automotive industry, you can leverage procurement volumes, you can leverage productivity by increasing automation, by increasing serial manufacturing, and that is our manufacturing strategy very, very clearly. At the same time, we are very aware of that we need to increase and enhance our supply base. We are doing that actually very diligently. We have defined different procurement packages where we are now also enhancing and broadening our supply base with. We're even investing in suppliers to ensure that they can cope with the demand that we are placing with them. And at the same time, it has the advantage that we can also maintain our IP. If we are investing in the tools that they use, they cannot use the tools for anything else than supplying us, of course. And that's also part of how we want to build up our supply chains and our systems. Of course, we are maybe not that far advanced in terms of our ESG activities as De Nora. We are on the stock listed only since half a year, but we have also worked already intensively on our sustainability strategy. Why? Because we are very well aware that it's an important and essential success factor in our business, and going forward it will be even get more important. So it's not enough that you offer fair trade coffee to your employees or to your customers. You really need to take action and to identify those areas where you say, okay, here we need to improve. Of course, intrinsically, we are already sustainable with the systems that we are providing, helping others to decarbonize, etc. But still, of course, looking at ourselves and what we have and we can to contribute, we have undergone a quite intensive discussion. We have done a double material analysis according to the GRI framework and so on and so forth. We have aligned and discussed with external shareholders and internal shareholders to understand what are the action fields that we believe are most important for us, and you see them here on the screen as well. We have derived from that our ambition levels, our targets, our KPIs, and we are currently already in the process of really implementing first measures. And we will have the opportunity to present our first report, which certainly we believe also we owe all our investors and all of you with the next annual report that we will issue at the beginning of our next fiscal year. So towards the end of this fiscal year, we're gonna be able to provide that. So that's where we are standing also in ESG. Again, we have also here quite a journey in front of us, but we're also keen to reach our targets here as well. Yeah, and with that, now we're coming to the more interesting piece, which is technologies. Our joint heritage, and we have here two, again, I would avoid the word dinosaurs of technologies, but these guys, they know everything about our technologies. And whenever actually you see something in the market where someone is announcing, you know, we are trying to do this, we're trying to do that, and we have a new thing here and there, I always go to Fulvio and say, hey, Fulvio, you know, look at this, they're doing this, and say, yeah, we did it 20 years ago, it doesn't work, forget it. So I hand over to those two guys, and you know, I'm very excited to have you here as well, and actually, you know, really looking forward to telling us actually how we've done in terms of innovation and what we are planning for the future. Thank you very much.
Thank you, and a welcome also from our side. Now we would like to have a deep dive into technology. I wish we could provide you some information and some elements that later on you could see in the workshop here in Rodenbach, something that you can see and touch. Okay, maybe touching not, as Robert said, but you could witness that is now concrete. It is real. We are delivering, and we have already initiated this journey to provide gigawatt scale manufacturing and then plants and modules. We come from a legacy and heritage of several years of development and innovation. I had the pleasure to participate to that personally, okay, not from the 60s, but from the 90s, from the early 90s. And that represents, with a few examples, what we could achieve and all the sequence of improvements in the industrial electrochemicals technologies. We will present that in a kind of dialogue mode. So, Christian, let's start from...
Thank you. Thank you. Welcome from my side as well. I've never been called dinosaurs, but my name is Christian Urgege, and I'm the CTO of Gruppo Nora. And let's say I'm gonna, with Fulvio, drive you through this journey. Here you see our innovation timeline. Actually, Nora started a little bit earlier than that. We started in 1923, and we were active in chlor-alkali, as Paolo mentioned it before. But we wanted to remark the breakthrough innovation that we brought in the market in the 60s, late 60s, which was the DSA anode. That actually revolutionized the market and was the first of many. The idea behind this development was to provide a material that was stable in operation. Of course, let me say, improving the performances of the existing technologies that were based on graphite. We brought in the market the titanium-coated electrodes, coated with mixed metal oxides. And the breakthrough here was that back then metal oxides were considered rust, so not conductive, sometimes catalytic, but not really useful for electrochemistry. And the development actually was so powerful that we unlocked the capacity of many of our customers that actually were able to double, triple the production capacity by increasing the current density with a very similar footprint. And this was for our direct customer. Fulvio will explain you the impact on the chlor-alkali technologies, but as well also for the final user, because we brought in the market something that was stable. Graphite was fragile, was not really stable over time. And so with our materials, final users were able to provide stable operation. Processes became more and more stable over time, and so reliability actually made the business really successful. Please, Fulvio, for yours.
Yeah, and the introduction of those DSA electrodes together with the ion exchange membranes triggered the development of chlor-alkali cells, membrane chlor-alkali cells. Here we have the examples in the 90s, almost in parallel, the BITAC, the first large-scale high current density electrolyzer, and also the BM electrolysis cells, BM single element electrolysis cells, which was starting with first generation, and the key milestone was in there around the end of the 90s, the BM generation 3 that was using also manufacturing techniques like, for example, the laser welding, which you will also see here, and the internal ways to enhance the internal recirculation. I will talk about that also a bit later.
Well, we didn't want to bring all the developmental step, but it was worth to mention the innovation we did in the chlor-alkali market around the year 2000. First of all, because I was also part of the patent, so I wanted to remark it. It was the energy patent family, which was an hydrogen generation cathode that we are, let's say, kept improving over the years. As of now, we are using it also in a different version in the water electrolysis, and many other coatings that I didn't want to mention, but that brought, let's say, the power consumption lower and lower in the years. And then, because we had a long experience back then in the fuel cell market, we decided to export, let me say, the so-called gas diffusion electrodes in the chlor-alkali market and hydrochloric acid electrolysis. We basically coupled the so-called ODC technology with the existing processes, and this brought 33% power consumption reduction in the field with a very sophisticated electrode structure, which is made of porous material that allows to add one more reagent to the reaction. So most of the time we bring oxygen in the cell, and this basically, it is the process that the reduction of the oxygen is the process that reduces the power consumption of these electrolyzers.
Yes, and those gas diffusion electrodes were implemented, or let me say imported then into the cells for the HCl ODC technology. ODC stands for oxygen depolarized cathode. It means there is a gas diffusion electrode in there, and that reduces the power consumption in the process of recycling HCl. HCl is typically a subproduct of other chemical processes using chlorine. Yeah, starts with chlorine, then you get as a byproduct HCl that is not easy to dispose or to reutilize, and then at that time we were able to implement such a technology for recycling HCl back to chlorine. That is the HCl ODC technology that we introduced also with our partner Covestro in all over the world, and it is the largest industrial scale application of those gas diffusion electrodes. We were in parallel continuing to develop our conventional membrane chlor-alkali technology. There is there around 2012, the generation 6, full zero gap, independent sealing. Sealing is an important topic I will talk about also later, and also the ODC inside the NaCl, conventional chlor-alkali technology.
Yeah, again, another piece of information in our timeline. So in middle, let's say, of the 2010, around 2014, we then decided to look, like Paolo was saying, a little more deeper into the hydrogen arena. And let's say we had a long history of development in cathodes involving hydrogen. We finally recognizing the alkaline water electrolysis is one of the most let's say, the favorite, I would say, technology in this market. And so we started working also on the other side of the reaction, so the oxygen evolving components, and we started the development of what was then the generation of coatings that we are using in the scalum electrolyzer.
Yeah, and that was starting with that milestone in 2018, our carbon-to-chem 2 megawatt demonstration unit. It was continuing with development in parallel because that is a strong synergy between chlor-alkali and alkaline water electrolysis with the eBITAC in 2020, a few years ago. And that continues scaling up. I would say that is a unique ability of our companies to bring the technology from the laboratory scale and the concept up to the large industrial scale. Our first gigawatt scale project, which was contracted with CF Industry, and our 20 megawatt module unit, now named Scalum. It's our output of this journey since a couple of years ago.
Yeah, and the last, let me say, focus that we had in the development of those technologies was, of course, the sustainability, as was said by Chiara, the sustainability of the technology, because let's say we wanted to contribute, let's say, to the power consumption of our customer, but as well also of the market itself, because we realized immediately that without a very conscious utilization of the raw material, we would not been able to provide gigawatt scale plants, and not for sure being able to serve a market of such size. As well, let's say we have been practicing the reuse, like Chiara was saying before, the recycle of the second life of our products in the market, and so we started also implementing this concept in the alkaline water electrolysis business. always, let's say, keeping, of course, the chlor-alkali well fed, but this became an obsession for my team, at least, in the last, let's say, five years, I would say.
An overarching message on top of this journey and time scale is that we were able to improve significantly the power consumption, which means energy efficiency, and at the same time increasing the current density. That means production capacity. That means also cost down for the same production capacity. And together those elements make the total cost of ownership for the production, for example, of hydrogen, which is a key parameter to be successful on the market. What is important, in my humble opinion, is that that comes with experience. Experience, it's very important. We have done all of that in industrial scales. We have done more than 600 projects. We have done more than 240,000 cell elements, equivalent more than 10 gigawatt, already with the chlor-alkali. Chlor-alkali was already producing on the cathode side hydrogen. This is now growing tenfold or more for the green hydrogen. And at the core of our technology, there is the cell element, the electrolysis cell elements. Here it is represented in the middle as the BM single element. And this is the result of an holistic collaboration among our companies. In order to develop and to be excellent and leading in such a technology, the role of nucera is to design the cell. I will explain a bit later what does mean the design of the cell, the design of the process, the design of the module, of everything to reach the product which is used for our customers. And inside the cells, the selection of the materials, the selection of components like the membranes or the diaphragms, as well as the sealing system, the gas-liquid separation, and so on. But that has to be seen as an interaction, continuous interaction and integration together with
with the Nora, it's complementing, of course, let's say the competencies of nucera in under the anodes and cathode standpoint. So we develop the components as well as the manufacturing processes for the electrode coatings for chlor-alkali, anode and cathode, standard chlor-alkali, and let's say the polarized units with the gas diffusion electrodes, and of course also for alkaline water electrolysis. Yes, of course, the holistic approach is happening in manufacturing because it's where actually we touch, let's say, more frequently the innovation that the Nora brings in on the table, and so is there we actually had developed technologies for, let me say, a serial production kind of activity to a real mass manufacturing in a gigawatt scale, and this, without spoiling too much, is what you're going to see later in the tour.
What does it mean, the design of an electrolysis cell or electrolysis cells? Here in the middle, we have a representation of a kind of hybrid. We can see on the cathode side, we have the hydrogen generation. That is valid for both chlor-alkali and alkaline water electrolysis. The feed, it can be caustic soda or KOH. On the anode side, it's a bit different. The plus side that you can see there in such a representation. In case of chlor-alkali, we feed salt, sodium chloride solution, or maybe potassium chloride solution, and we generate chlorine. So when moving or we're evolving from the chlor-alkali to the green hydrogen alkaline water electrolysis, we could, of course, take the synergy of already known since many years hydrogen evolution on the cathode side. On the anode side, it was, and it is, a bit more challenging. Okay, we replaced the titanium materials that are used in the chlor-alkali with materials that are suitable for the generation of oxygen from the splitting of water for the alkaline water electrolysis. What was needed here is, of course, a combination of different disciplines in terms of design. Electrochemistry means the combination of electrical or electricity and chemical processes. So what is important here and make the difference is the hydraulic design. We need to feed the water or the brine solution to the electrodes. The design of the cell internals, it's in order to have an equal distribution of the electrolytes, the solutions, the reactants to the electrodes. but also to keep uniform the temperatures in order to have efficiency in that reaction of producing hydrogen and oxygen. And also uniform pressures. This is why there are gas-liquid separation chambers in order to damp down possible pressure fluctuations that could be detrimental for the longevity of the cell and of the performance. This needs to be coupled and interacted with the mechanical design. For mechanical design, key important is the sealing system. We need to contain those electrolytes and gases inside the electrolyzer reactor. So the sealing is very important. In our cell design, we have a rugged sealing system with individual cell sealing, which is independent from other mechanical reasons that provide safety and reliability. Electrical design, it's also the art and science of delivering the current where it is needed in a uniform way so that the electrolysis happens uniformly, and at the same time we do not lose too much energy because the current can have some resistance in the metal. So, and also the manufacturing techniques in order to weld together those parts is a contribution in this holistic collaboration. On the right side of this slide, you can see a key feature of our technology, which is the zero gap. That means that inside the cell, there are anode and cathode electrodes that are close together without any gap to the separator, which is a membrane or a diaphragm. That provides the best efficiency. In the same time, it's necessary that this closing together is gentle to the membrane, not to stress it, not to blind it, to allow the flow of the electrolyte and the ions through the membrane. The electrode, the anode electrode, and the cathode electrodes needs to be designed with a shape which is allowing the gas bubbles that are generated to move out from the reaction zone and to be replaced by the liquids, KOH, for example, or water, that need to react. So this is, can you see, maybe represented on the right side of this picture. So in the case of the hydraulic design is in the macro and the middle size affected, or let's say it is depending on the electrodes design. All of that brings to a very important feature, the high current density. In comparison to conventional technologies, this is running, in the case of green hydrogen, at 12 kiloampere per square meter, or 1.2 ampere per square centimeter. And that is possible through that design, through those components, especially the thin diaphragms, that needs to be treated in the proper way to survive and to be there for several years without a significant degradation. That, all of that has to be combined with Christian.
Yeah, with the development that the Nora brings. Honestly, I have to bring you a little bit on the micro scale now, because the design, the innovation of the Nora is really in the fundamentals of the technology, and so in the micro scale. So we start from the catalytic center. So the coating, it is where the reaction occurs, where the catalysts normally facilitate the reaction and make them happening, and it is on a very small scale. So I can show you some pictures here of the product. You see in the gray pictures are 10,000 magnification already of our coatings. On the bottom you see the surface. In the cross section you see, let's say, the profile. And the catalyst has the responsibility to make the reaction occur with the lowest energy consumption possible. And so, as you can see, it is not a simple structure. It is complex, it is articulated, and it is designed to be like that because it's not just chemistry and say structural on the micro scale, but there is also a meso scale that you have to take into consideration to guarantee longevity during the time. Then there is a further magnification. You see the pictures in yellow are actually 20 million magnification. This shows you with some models as well how the water molecules interact with the catalyst differently depending on the catalyst itself. So I hope you will appreciate how important it is, this kind of step to make really the difference in the process. Of course, it is not, let me say, all on the micro scale and in the nanoscale, but there is also the contribution of the design on a little larger scale. So we use the same tools that nucera uses for the design of the structures to understand how the electrodes will work at the final step. So we check, for instance, those gas formation, these bubbles, where they're coming from, how the current density will distribute with some modeling, finite element modeling. And so we design where to put the catalyst, because let's say in the optic of making sure that we don't waste materials, we have to select where actually the catalyst will work at the best, where it will not be, impeded in doing this reaction. And let me say, so this is more or less what we do. Thank you, Fulvio. So again, without let's say anticipating too much the tour, we wanted to give you an idea of let's say the holistic approach that we are following, and I hope you have understood that the development and the innovation that both companies brings in the picture are nice, but they have to come together. And so it is really in manufacturing that we see the synergies between the two companies, and let's say in the final product you see the perfect combination of the expertise of our companies. And so here, starting from raw material, you can see how the Nora develops the coating solution, which is our proprietary formulation that we apply differently depending on the product, on top of the electrodes structures that nucera has developed and designed, and that as well proprietary of nucera. Then we take most of the time coils and few components, and we manufacture, let me say, the cell bodies, which is, let's say, the hardware portion, and we assemble together with electrodes and cell bodies the so-called cell elements. Fulvio will be explaining you how many cell elements makes a stacks and electrolyzer later on, but it was simpler to do it in this way, in this little sketch. This cell elements actually reaches the final user, and it is operated, as we were saying, for years. We can call them life cycles, and our let's say heritage, our let's say story, enable us to have multiple life cycles on the same hardware. So with process that we will call later services or refurbishment, or internally we call it recoating, but let's say we are able to get 3-4 times, let's say 3-4 life cycles of these elements at the customer site. Sometime during this process, we provide technology upgrades to the customer, so making sure that they are keeping up with the market development, so they don't get obsolete equipment at their site. And only when, let's say, they are really exhausted and at the end of the life of the elements, we come back, the elements come back in the Nora, and again, with some proprietary process, we make sure that everything it is either reused in other technologies or fully recycled in the stream. The proper stream.
Beyond the cell element is the first building block. Here named A cell element, on the left side of this slide. It means that the half shells, the anode and cathode half shells, which are manufactured here, come together. Of course, we need to assemble in between a separator, a membrane, or a diaphragm. We need the flange, the balls, the other components like internal tubes and so on. That makes then the single cell element. This is already, from the modularity point of view, the first building block. Modularity and standardizations are beyond the single cell element. So we also designed and assembled together the process units, skid-mounted process units at our module yards, in order to bring together 300 cell elements in our scalum 1.0 into 4 separate stacks. So again, it is modular, 4 stacks, and the process section, which is for the handling of the electrolyte, for the handling of the gases, and of course instrumentation, gas, liquid separation, and so on. And all of that then is shipped to the customer site or the plant size, where we can assemble together already pre-manufactured standardized modules that fit together in a fast and quick process with different efficiency in terms of timing in comparison to the project style building directly into the plant. So it's for saving time, it is for improving cost, efficiency, it is in general to provide modular, large-scale industrial plants. This is a difference in comparison to the chlor-alkali. In the chlor-alkali experience, we have been providing solutions highly customized. It's difficult to find a plant in chlor-alkali which is equal to another one. Why? Because the feedstocks can be different. The salt and the brine can be different. The location or the area or the building already available for the customer may be different. The space available may be different. The product requirements in terms of quality of chlorine or of caustic, and they depends on the use of those chemicals, which could be polyurethanes, disinfection, whatever. So again, it was a project business. Here for green hydrogen, we believe that the feedstocks are always the same: water, electrical energy, renewable electrical energy, and the output is hydrogen, byproduct also oxygen, which can also have a value. And that is calling for standardization, modularization, repeatable business in order to achieve most efficient and effective gigawatt scale. And here we see our product. The Scalum is our 20 megawatt unit. The features are in the range of, we see there, safety. I mentioned before, this ceiling, each single element, which is also represented there, goes into the stack. Each single element can be monitored individually. This is different than other alkaline water electrolysis traditional stacks that have internal manifolds. You close a stack, you don't know what happens in between. It's not visible. That we can monitor individually. This provides safety and reliability, and of course quality. In addition to that, we have the high current density, the 12 kA per square meter. That is a feature that provides flexibility of operation. The 12 kA per square meter and our units can operate between 10% and 100%. That can be coupled with fluctuating renewable energy. Our units can be shut down without issues of corrosion because of our processes, because of our components, because of our coatings and our design. That provides additional longevity. Our cells are designed in order that after whatever, 5, 8 years, are not becoming scrap, but can be reused. The coating has to be renewed by cell refurbishment. Means recoating, remeshing. The separator can be replaced after a certain lifetime. Some sealing can be replaced, but then you can reuse those cells for 30 years or more. In addition to that, it is also the high current density providing compact footprint. And this is also a value because we have to think about gigawatt scale with hundreds of those 20 megawatt units. And then everything is standardized, and the serial manufacturing is provided for that in order to be the most effective large-scale industrial electrolyzer provider. This is a picture of one of our modules. It's huge. I hope later on you could have in our tour here in Rodenbach to have a virtual experience with that. It's real, yeah? The size is unbelievable. And this is now provided already to our customer in the United States, in Saudi Arabia, also to our being provided also to our customer in our customer Shell, yeah, in the Netherlands, the Holland Hydrogen One project. In addition to that, we never settle. Yeah, we cannot rest. We need to continue development. Our DNA is to improve it, as in the first slide. Yeah, better, improving efficiency in power consumption, increasing the current density, or in general the cost down reduction. And we are already doing that. Incremental development. We call it now our Scalum 1.0. We are already working on the Scalum 1.1, 1.2. which will be available for the next projects, as well as for services to the existing projects where we could replace cell elements or we could introduce retrofitting, revamping all along the life cycle of the plants. We are working on the serial manufacturing growth, we call it a H2 Giga. We are also working in parallel to a second generation of electrolyzer design, which is aiming to have another important step in total cost of ownership. We work also on the process of standardizing and automating the manufacturing. We're with the colleagues of the Nora, as well as the assembling of the cells. Automation for assembling of everything up to the complete module. And we have a plan for that to increase automation cost down to achieve multi-gigawatt fabrication level in the next years.
Yeah, the development from the Nora side would have been a little bit more boring because it's most chemistry related and let me say micro scale. But we wanted to give you, let's say, a little flavor of what we are actually doing. And of course, we are developing all kind of formulation in the market we are present. So the chlor-alkali is one, standard chlor-alkali or depolarized, as I was saying before, and water electrolysis with the aim to reduce the power consumption as much as possible in these fields, as well as we are reducing our consumption of critical metal, and let's say in general, let me say in the transition business, but in general also in the other markets. And we are always exploring new cutting edge technologies in the frame of decarbonization and energy storage in general. I would not be, let's say, fair if I actually wouldn't speak about the innovation in the manufacturing that we are doing. And this, let's say, I think it is the core of the competitiveness of the, let's say, the total cost of ownership of our customer, because behind the gigawatt, let's say, scale manufacturing, there are single improvement on all the different processes to make them compatible with the reproducibility. And so here I put a couple of pictures of one of the processes, which is the laser welding process. I mean, we have been pioneering the laser welding, but let's say the scale was not like it is today. So we have been doing a semi-automated process. So of course the laser was automated, but you know the number of elements were not large enough to justify big automation. Last year, for the one I've been in this tour already, we have introduced some automation, and we already were able to achieve gigawatt scale production. You see the picture here, and the next step you will see it in the factory, where we had achieved full automation of this step with also digitalization of the process itself, which will bring us to another level, another scale. Thank you, Fulvio. So the manufacturing excellence for the Nora has always been to produce with the highest quality in the market, with reliability, with performances which were not being, let's say, have not been achieved by anybody else in the market, and I would say at a price which is compatible with the market requirement. Of course, our aim was always to monitor the consumption of natural resources, so our factories are actually not consuming, let me say, wasting, let me say, water sources. We are very careful with the consumption of electrical power, liquid natural gas, and raw materials. As you will see later, we don't scrap basically anything without recycling. And I can say that our technology now has reached a level of, let's say, friendly approach to the environment, let me say. So we don't significantly harm the environment during our manufacturing process, which was a big result. And of course, on top of this, we have, let's say, injected these reproducibilities, this capability to replicate our process on a scale in a singular factory and in other location, keeping the quality at the highest level in the market. Thank you for. So this is our, at the moment, reach. So we have 2.5 gigawatt equivalent in elements, let me say, of manufacturing capacity spread all over the world, like Paolo was showing you before. Mainly, this market, it is pursued here in Rodenbach, and you will see later the facility. But, of course, we have a strong contribution for our sister companies. We have announced last October, I think, the expansion of the Chinese plant in Suzhou. Next week we are going to be in Japan for the inauguration of the Okayama expansion as well, to serve as well this business. And I think it is now well known in the market that we are starting the greenfield project in Italy called the Gigafactory. It's going to be a massive, let's say, installment for hydrogen product manufacturing in Italy. This has been financed by the EPCA project. We have been one of the few companies awarded in Italy for the electrolyzer manufacturing. And as well, also here we have been spoiled by the DOE. We have been awarded by a large grant together with Nucera in the United States for, let's say, we call it Innovation Center for Energy, but it will be a manufacturing facilities that overall will bring us to a capacity of 4.5 gigawatt by 2026. So that was my last. Please, Fulvio.
I'm not tired to repeat again that services are part of our strategy, part of our business. Services are very important in terms of sustainability for the recycling of the cells, what we have mentioned before, reuse much as possible of the materials that we have in the new installations. But it's also business, yeah. In chlor-alkali, nucera makes roughly 50% of business with proper margins in the chlor-alkali. In the green hydrogen NWE, it will become later because we provide cell elements and components that last for targeting 80 years or so, but it will come with cycles. And there we are already prepared to provide services in terms of supporting the customers for all the life cycle of the plant, with replacement of membranes, replacement of components, sealing systems, assembling, yeah, we can help in order to avoid any quality issues. We can also introduce element upgrades with the latest novelties, like could be the latest coatings developed by Nora or design components developed by Nucera. We can replace elements, new generations, and altogether, yeah, we offer such services to our customers with Nucera providing the 360-degree service so that the customer can be fully satisfied with our offers and our support. After that, yeah, we would like also
listen, yeah, as well something.
After that, and talking about our customers, yeah, we wish to show you what our customers, because at the end, yeah, we would like to serve our customers to be jointly successful. We have here a short video from one of our partners, Shell, regarding the hydrogen, the Holland Hydrogen 1 project, which is a 200 megawatt plant. So it will be 10 of our module units. And yeah, please listen, enjoy
let's listen.
At this short video. I hope it starts. Yes, okay.
Dear colleagues, I was asked to share a few words on our cooperation with thyssenkrupp nucera. My name is Bas van der Werf. I'm project manager of Holland Hydrogen 1, the flagship green hydrogen project for Shell in the Netherlands, 200 megawatt plant capacity currently under construction. We are very proud on the cooperation we have with thyssenkrupp nucera. It started a number of years ago when we run the design competition. It was really heartwarming to see, even though we had some commercial challenges in the beginning of our cooperation, but how closely associated our engineers were and really talking the same language, that understanding the technical design, even though it was not fully mature, gave us a lot of confidence. Not only by the engineers coming together, the cooperation with the Nora, it was clear that there is a deep technical expertise in the organization, which we highly regarded and is built on the long-term experience TK nucera has in the chlor-alkali market. That gave us quite a good confidence. The other element was around competitiveness. We looked into, well, what does it take to integrate multiple electrolyzers in a running plant? So cost differentiating elements like the size of the building, the amount of electrical connections, the physical footprint of the units were all considered, and in the end that allowed us to draw the conclusion that the proposal from TK nucera was most competitive at that time, which was very well received. Last but not least, ability to deliver. It sounds relatively high level, but we truly believe that in the current green hydrogen technology market, there are very strong players like yourselves, but there are also players who seem to be a bit more active on LinkedIn than what their real ability to deliver is. And we were really pleased to see that you have the ability to fabricate in-house and really focus on items which are your core competency and where your intellectual property resides, but also for areas that you make use of selected fabricators worldwide who on your behalf assemble the modules, and we are really pleased with that so far. 8 out of our 10 modules are currently nearing ready for shipment in Tarragona in Spain, and yeah, the cooperation on that with TK nucera has been really exceptional. Of course, we still have a long way to go in fully assembling the units still on site, making sure we can safely commission them, start them up, and yeah, have a running plant which provides value to the Shell Group. So looking forward in the coming 2 years to deepen our conversations even further on commissioning, startup and operations, and making sure that yeah, the units in the end perform as intended. So have a good day. Thank you very much for all your cooperation, and bye-bye.
What can I say? I think that you have now seen that a unique combination has provided unique solutions and products to the market since many, many years. And of course, you know, looking ahead, actually will jointly further create and further build a real champion in the green hydrogen environment and industry. So that I'm 100% convinced of. We have all the prerequisites. We have great teams. We have a strong balance sheet. We know what we're doing. We have a great history. We know how to deliver. We can jointly you know, provide all of that to our clients and even the guys. And you know, if you have ever worked with Shell, you know they are not the most simplest client in the world. And if they are basically happy with what we are doing, we can be very proud of that. And we really believe that, you know, going forward, we will be able to show and demonstrate to everyone that this is a real leader in the industry. Thank you very much yeah, for listening to us. And I do believe now the floor is open for questions, be it from our audience, I think online as well.
Yes, so for the online, thank you so much. For the people watching remotely, you can send your questions via email to the Investor Relations Department, and we will make sure, maybe not today, but as soon as possible in the upcoming day, to answer them and get back to you. And for those being here physically, please raise your questions. We have some microphones, and answer all of them today, hopefully.
Thank you. Good morning. It's Martin Wilkie from Citi. I had a couple of questions just on the sharing of intellectual property. So you've highlighted which parts are De Nora, which parts are nucera. Are they always distinct? Is there cross-licensing of the technologies? And when you think about developing in the future, is that an efficient way to do it, that you have such distinct parts that are owned by the two companies?
So I think that the distinct capabilities in innovations became clear. It is always also what we want to maintain going forward. So there is no requirement for cross-licensing or anything like that. Actually, you know, De Nora is the expert in the market when it comes to coatings. We are providing the design of the cells, and we're doing, you know, the system integration, all the process, etc., and so on and so forth. And it's the joint, you know, effort, I think, that makes the difference here as well. And it's certainly something that we want to maintain going forward as well. So.
Thank you. If I could have a second question as well. On the service element, you highlighted that the recoating is done by De Nora, many other parts done by nucera. In terms of the value share, when it comes to servicing an electrolyzer, you know, how much is the recoating as a percentage relative to all the other parts that happen?
Well, it's a difficult question. It really depends actually of the status of the cells, so to speak. But at the end, basically, how we approach that is that we are the face to the customers. We are actually being the one doing the revamps actually, and we have De Nora doing the recoating of the electrodes. And if in some cases the electrodes needs to be completely replaced because they have also degraded and shown damages, we also have to look at the individual cells, what needs to be done actually to refurbish them, and then they are put back into operation. So it's very difficult to say how much it is. Of course, you know, you can assume that, I mean, there's a lot of value in the precious metal, so it is a significant portion of the overall cost, of course, as it also is in new cells as well.
Thank you.
Sure.
Maybe before over here in the front. Yeah, thank you.
Thank you. Johan Charton from Société Générale. I would like to ask two questions. One is on the TCO, because I think, Fulvio, you referred to it. Are you able to provide some color where you stand versus a typical benchmark in the industry with your scalar module?
Well, as you know, the TCO depends a lot on which kind of operation scheme is considered. Yeah, it depends if it is a continuous operation, if it is fluctuating energy, depending if it is connected from the solar power or wind power and so on. Yeah, so we do not have now a standard benchmark. What we can say is that when we are confronted with our customers, it results that our TCO is quite competitive. You could see that because our technology is advanced alkaline water electrolysis, the initial capex, yeah, it's in comparison to conventional AWE, it's higher, but that is compensated by the long-term energy consumption as well as the lifetime of the plant. And so I do not have in mind now precise figures. What I can say is that we are successful in that.
Okay, fair enough. And if I may ask a second question, again, Fulvio, apologies.
No.
I remember you presented, I think in early 2022, during the first capital market days that introduced thyssenkrupp nucera to the investment community. You presented a technology agenda on the day, and you referred to your expectation for a quantum leap in terms of technology platform in 4 to 5 years ahead. Are you able to provide an update on this journey?
We are working, as I said today, the second generation. We cannot yet disclose what is the content of that for obvious reasons. We aim to have it ready for the market in, do we have a date, 2020?
It's his commitment.
2027.
But we believe that 2027 actually
2027
we should be in the position that it is really, you know, due to be commercialized, and it will, of course, for a certain period of time. Actually, it will also run in parallel with the existing 1.0 scalar technology, because, as you've heard, there are also possibilities and opportunities to upgrade even that technology with new coatings, with new features, etc. So it's not that we, you know, we leave customers with old technology and provide something new to the market. So that will be running in parallel since for many
several
years.
Yes.
Thank you.
You go next, please.
Hi there, it's James Carmichael from Berenberg. Just had a couple, please. First, you mentioned procurement packages in the supply chain. So I was just wondering where you see sort of potential bottlenecks in the supply chain and where it is that you're having to invest to support them. And then maybe just coming back to the last question on technology, I think you said 2027 for the big step change, but in the interim there'll be some maybe more incremental improvements. Are you able to say sort of where you're targeting the incremental improvements, what we might see versus sort of scaling 1.0?
Okay, the first one I'll do, the second one, if you may, So in terms of the procurement packages, I mean, and that holds true for our overall supply chain, there are, I would say, very specific components. One big example is certainly nickel. We use a lot of nickel. And we use it actually in very thin nickel sheets. You will see that actually in the factory here as well. That's a very specific form of nickel which is not readily available across the planet. So here we have identified a number of suppliers that are able to deliver in large quantities and in the quality that we're requiring those nickel sheets in form of coils. And we are securing here with frame contracts large amounts of those nickel quantities over many years. So just to give an example, there we have one supplier where we just contracted, I think last year, within a frame contract, nickel good for roughly already 2 gigawatts of electrolyzer capacity. So that's the way how we work with our supply base to ensure that we build up a resilient supply chain for our electrolyzers. And as said, for some of these critical components where we potentially only have a few suppliers, and it's very specific to what we are doing, we are even investing in those suppliers to helping them also follow our growth.
And
improvements.
Could you kindly repeat the question about the...
It was just whether you can say anything on the sort of incremental improvements where you're targeting better performance versus 1.0.
Yes, okay. As I said, we would like to improve the existing technology basis with the next steps, scaling 1.1, 1.2, and yeah, we could say only in due time, yeah, when those results will be available. Important message is that the today technology is ready and competitive. That is our situation. For sure, we would like to have those improvements or retrofitting at the time of refurbishment, which is relatively far away, 6 to 8 years. So that is definitely our target. But we may release something in between, depending also on the continuous development of the components, like what was mentioned also by the colleagues of the Nora, the reduction of precious metals, of novel metals will be step by step introduced in the next years in the range.
So all of that is typically targeting either increased performance or lowering cost, or ideally both of that. So one good example, I believe, is a joint development that we're currently working on, is to reduce and to get finally rid of any iridium in the coatings. There's still some small amounts of iridium in our coatings today. We all know that this is and will be a bottleneck in the growth of those kind of technologies. We know that we can get rid of that in alkaline water. We have already some test candidates in our pilot plants. I mean, you potentially, Christian, can talk about that a little bit more detail, which will provide a similar performance without any iridium, and with that lowering the cost and sort of removing a bottleneck also in terms of growth.
Yeah, some of those steps we have already achieved, and we have included them in the scale 1.0. So the message that I would like to convey is that we don't like bungee jumping. So every change that we want to do, it is well validated in the lab first by the Nora. And coming to the question before, there is a value in having, let's say, this relationship because we challenge each other. So we have our development. When we are ready, we try to convince nucera that it is a good improvement. Then we wanted to test everybody together in the facilities in Duisburg, for instance. And so the next step will be a further reduction of iridium, which has been already, let's say, qualified at the largest scale possible at the moment. And the next one, the next after, will be another improvement in the power consumption. I don't know if it will be enough to release a 1 point something technology, but that's for sure the two step. And of course, like was mentioned by Werner, say the cost down mostly refers to the amount of iridium that we have in our formulation, and optionally, let's say, we would like to remove also the others, but let's say we focus on the critical ones first.
I think there was a question in the back, and may I ask you to speak a bit more closer to the microphone and or a bit louder because there's quite some background noise coming in. Thank you.
Okay, I'll do my best to be understandable. Mike Kuhn from Deutsche Bank. Two questions. One on technology. A few days ago, you announced a cooperation with Fraunhofer Society on SOEC technology. How does that fit into your technological roadmap? And let's say, how are the timeframes we should think about in the context of that project? And on a different note, you also mentioned the 50 million grant from the US government. There's lots of discussions on, let's say, trade barriers, etc. How do you think about your, let's say, production footprint in the context of the US and potential trade barriers, tariffs, etc., coming up maybe after an election? Thank you.
You wanna? I can take the solid oxide electrolysis cells. Yes, we made now an agreement with Fraunhofer IKTS about the development of those high temperature electrolysis technology that is ideally complementing the AWE, because that has a much better efficiency when it is possible to use waste heat. Processes like steel production or also ammonia production generate a lot of heat that can be fed as an energy together with the electricity to make the splitting of water. So the energy consumption in terms of electricity consumption is much better than alkaline water electrolysis. 15 to 20% better efficiency. Of course, if you have such a waste heat. The technology has not the same maturity as the alkaline water electrolysis. So we see that will take some years until it becomes commercially available in industrial large scale. Yeah, we are always the people for the large industrial scale. So those units will need to be integrated into modules to make the gigawatt plants. Another point is that technology is working at high temperature, and for such a reason is designed or intrinsically not able to follow quickly fluctuations. Yeah, you cannot drop down from 800 degrees C down to room temperature if you need to shut it down. So that is ideally better fitting to a base load which is constant, while the alkaline water electrolysis could be for the fluctuating load. So we believe it will be a combined installation of both. We are starting now such a development. We need to see and to bring, our aim is to bring that to industrial serial manufacturing, because the technology works, but it's still at a kind of, let's say, technology maturity level of 7 or 6 or 7, something like that. It's not yet in the industrial field. And it will take some years until the end of the decade.
And maybe to add on that, in addition to actually that complementary feature, if you want, high temperature technology can also open up a new application field, simply because you can do co-electrolysis. So you can not only feed water and then split water into oxygen and hydrogen, you can also feed water plus CO2, for example, and with that generate hydrogen and CO, carbon monoxide. This combination is called syngas and is a classical feedstock for a lot of basic petrochemicals. And with that, you could produce basic chemical materials actually on a sustainable basis, just as one example. Another example is actually you can also feed ammonia. And you can split ammonia back into hydrogen and nitrogen in such an electrolyzer. You know that around the planet currently everyone is trying to figure out how to crack ammonia actually thermally back into hydrogen and nitrogen as a means of having it transported over longer distances as ammonia and then cracking it back into hydrogen to use the hydrogen. That is a potential application also for co-electrolysis using high temperature electrolysis. So there are additional fields of use which provides for us then a larger access to a market which alone with alkaline water or any other electrolysis technology is not accessible.
That is another building block that will expand our capabilities in our technology roadmap, it will not offset AWE. This is our target.
Now, timeline-wise, we've just announced that we've closed now that cooperation. As part of that cooperation, the IKTS will build together with us a pilot manufacturing plant line where we jointly want to learn how to really produce the cells and the stacks in a mass manufacturing approach. You need to consider that the cells are just like 10 by 10 roughly, so very small compared to what you've seen actually with those large single cells in the alkaline water field that we are producing, and which you will see also in the manufacturing side here. So you can imagine you need millions, if you want, of those cells to really go to gigawatt scale, and that certainly can only be done in a real mass manufacturing process. And that is something that we are now jointly developing and then put into scale in the next step. So the pilot plant will be up and running beginning latest mid of next year. And then we believe we're going to have a learning phase of maybe 1 or 2 years before we are ready to scale it up into a next step, which will be then in the range of 300 megawatts of manufacturing capacity, and then finally moving into a gigawatt scale once we see that working in that particular scaled up facility. So if you, from a timing wise, you look at that, then basically I would believe towards the end of the decade, we will see larger scale manufacturing capacities and full commercialization also of overall systems. Don't forget, this will only be this collaboration on the stack side, on the cell side, but then our competency come into play anyway, still to integrate that into an overall system, to build a system actually that can be industrialized, that is also matching and all the requirements of an industry, and can be then reliably and robustly actually be deployed in the market.
That's our role, yeah, the engineering in order to have the integration of all of those relatively small stack into systems, and then it will be also the integration with the other plans we have already in mind in the future, some cooperation with our colleagues of decarbon technologies, for example, or other applications.
And US funding. Sorry, second one, US funding. I mean, of course, and I think Christian has mentioned that already. What we want to do in the US, based on being now selected for 50 million on funding, is also to build up there at the end our manufacturing footprint, be it on manufacturing the cells as well as actually the final assembly of the half shells. Ideally, we do that in a fully integrated setup at one location. That also means that we still have to develop new, or let's say advanced manufacturing technologies, which is something we're going to do under that support of the DOE. And then finally, actually, the aim is to have that manufacturing site available. This manufacturing site will be almost 100% geared towards supplying the US market. And we believe the potential in the US is very, very significant, and that will be easily absorbed by the market, what we will be able to build up here jointly in terms of manufacturing capacities. So with that, we will certainly avoid the discussion around, Buy America's Act and all the different regulations that are already in place. They're currently not applying to electrolyzer manufacturing, but they can going forward. That can certainly change. We want to be prepared for that, and that's certainly also a factor why we believe we need to build up something in the US also when it comes to manufacturing.
Next one would be you, sir.
Thank you. Sky from Redburn Atlantic. Firstly, the scale-up required for NEOM and H2 Green Steel's already been significant. So can you share some of the learnings from the ramp-up process that you've done already? What's been easier than expected? What's been harder than expected? and then and how that can be applied to Milan and the US. And then secondly, if we fast forward like 10 years, service aftermarket is going to be going ahead for NEOM, H2 Green Steel, and other projects. Is the facility or the roadmap of 5 gigawatts, is that going to be enough to facilitate the aftermarket as well, or will you need additional facilities to do the aftermarket servicing, assuming that the industry demand for greenfield is strong?
Yeah. So we said that, the last question first. The 5 gigawatts are a manufacturing capacity that initially actually should supply new systems, of course, right? And we said we're going to be ready with that by the end of our fiscal year 25-26, which is very much in line with what also De Nora has told actually, how they're going to build up their manufacturing as well. That doesn't mean that actually we stop there. And of course, if you consider that the first real peaks in terms of services when we do those refurbishment of cells will start between 6 and 8 years after the initial startup of a plant, and we will be ready with the 5 gigawatts 25-26 towards the end. There will be not a big service business already at that point in time. The service business will come later and needs to be also served by an increasing capacity actually that still needs to be built up. So we are further ahead, certainly also want to further increase our capacities jointly with De Nora, also to support then finally the service business.
If I may chime in here just very quickly, the electrode manufacturing capacity of De Nora is well above that what we showed.
Yeah.
Here are cell equivalent, but in the, like explained by Fulvio, in the recoating refurbishment process, we are actually providing electrodes which on which we have a much larger installed base than what you have seen here. Of course, we are at this point not all here in Rodebach, where we do have manufacturing hub in Japan, China, and the largest one, at least, United States. Then we have also Brazil and India with the same more or less capability. And we are expanding as well in our plant the manufacturing in Italy. So electrodes-wise, we are, I think, 5 times more, if I'm not mistaken, nowadays, what you've seen as per cell elements. And let's say the future is to be depicted, but yeah.
Learnings from scaling up into really now large scale. I think it would be a lie if we would say we have learned everything already. I think we are still learning while we are actually also delivering those big projects. And I think this was also the purpose of it, to really learn how that needs to work in large scale and what needs to be changed. One aspect, for example, is that we are now clear on you cannot continue as we've done in the past to fully manually assemble individual cells on site, which we have done in the past with chlor-alkali all the time, because you were delivering a couple of hundred cells, if you want, can be easily IKEA-like assembled on site. That is impossible with 33,000 cells, which is the number of cells that we would have to assemble, or that we will have to assemble for NEOM alone. So we need to automate that. So there needs to be also here an automized process. And I think Fulvio has mentioned that already. We're working already on the different technologies and methodologies to get all of that automized. We have worked intensively already over the last couple of months with the automotive suppliers in the market to design assembly lines for us. And we will implement going forward such assembly lines in the form of a hub. So we will have a hub in Europe, we will have a hub in the Middle East, we will have a hub maybe in the US, and so on and so forth, to from there supply the closed, fully assembled cells to the sites where they will then just be hanged into the racks and interconnected. That's the principle that we want to apply, and that's certainly one of the learnings that we did from NEOM. I think another very important one is consistency of quality. You need to get out of that, with all respect, garage kind of workshop approach. Yeah? In Germany, we would say Bastelbude. That doesn't work. Of course, you need to be very clear and very precise on your processes and on the consistency of your quality. Every little mistake will cost you a fortune because you're multiplying that by I don't know how many modules at the end. Yeah? And that is something that we are now doing very, very diligently also in our module yards. which we have subcontracted to manufacture these big modules, and you've seen that explosion sketch actually of that module. It looks like, you know, different Lego bricks that you finally can then reassemble together. That's exactly how it is meant. And those individual kits, they need to be built to a very specific quality. So we have our own quality teams available and always permanently on site with our manufacturing yards to ensure that, you know, quality is right, they are on time, they're increasing their productivity, and so on and so forth. So just to give you an example of two learnings that I think are very important actually in that framework.
Thank you. Next question over there. Yes, please. No, you go.
Sorry.
You were first. Oh, so
yeah,
okay.
It's Matteo Bonizzoni from Kepler Cheuvreux. I have a question for the CEO of nucera on your pipeline. You released a strong statement because you say that you have 19 gigawatt of negotiation, and in the next 18 months you are confident to achieve around two-thirds of that, no? So this would mean 4 times what you have achieved so far, no? Which would be very, very strong achievement in my view, and I think also in the market view. The question is the following one. Can you help us understanding what you are observing on the market in terms of attitude of your customer to get to a final investment decision, and maybe provide a little bit more color on the end markets, so end user, in which sector you see more traction, and also geographies? Thanks.
Sure. Maybe then at this point in time I was not clear enough. I didn't say that we will win every of those 19 gigawatts of projects. We believe that those 19 gigawatts of projects which we are currently working on, they will be moving towards FID in the next 18 months, signing contracts. But not all of them will sign contract with us. So of course there is always competition. We are not exclusive with 19 gigawatts. And of course we believe we will win our fair share, which will be less than 19 gigawatts, but large enough for us to follow our growth plans and certainly fill our capacities very much. What we see in the market right now, and I think it's also not a big secret, if you look at the last year, very high interest rates, uncertainties in terms of regulations, slow funding applications that didn't really help our clients to move ahead. And this is why we have seen in many different cases also delays, clearly, right? Where did we see most of the delays? I would say with the classical project developers, because they found out all of a sudden, they don't get a bankable project because, you know, the interest rates are so high and they don't have an offtake, right? What we see also in the market are that those projects and those customers, they are moving quite well ahead, are the ones that more strategically invest. The ones like the industrial gas players that do have their own offtake, right? So they have everything together. They can develop, if you want, the overall ecosystem. And with that, basically for them, it looks like it's way easier than it is for other clients. Similar also for clients that develop also the overall ecosystem from the renewable energy supply, be it wind farms and solar and what have you, down to the offtake, like for example NEOM. I mean, that was a classical case. It would never have happened if they would have not developed everything in one go. So I think we see now two different movements in the market. The ones which are more on the project development side, they find it way more difficult than they expected actually to get bankable projects. And we see on the other side the more strategic investors that are moving further ahead. For us, that's good news because we tend to work with strong partners like, you know, Air Products, for example, but also others where we know that they are looking at that very strategically actually, and we also see that they are moving ahead. Others maybe struggle a little bit more with the situation in the market. In general, what we see in the market, and if you just look at the US, just at the beginning of the year, the first draft of the rules was issued by the Treasury Department on the V45, so on the tax credits that would be available for the producers of green hydrogen, and the rules are certainly around what defines green hydrogen. And the rules were pretty similar to the rules actually that are already in place in Europe, which are seen as being very strict. very strict in a way that actually, of course, if you have to follow the intermittent profile of a renewable energy source very strictly, then it also means that you cannot produce 100% all the time. Very logic. That means, of course, that your specific cost per kilogram of hydrogen is going up, because you cannot use the full operation hours actually of such a system. That's something that is currently under revision again, as far as we have understood. Also in the US, it'll take maybe a couple of weeks before actually there will be a final call here. We see that actually also our clients are eager to understand and at least understand signals in which direction this is going. However, when we talk behind closed doors with our clients, they also tell us, even with the strict rules, it's a very nice business case still for them. So it's not gonna really change anything, but we see, of course, with those unclarities, still a couple of delays. In Europe, the delays that we see right now are very typical delays from lengthy application process. I mean, if you just look at, if you would have applied for the IPCEI funding, actually, you would have done it maybe 2 years ago, and you still have not received the grant, potentially, right? So you see this a long period of time, but we see this now really rolling in. A very good example here in Germany is the funding that all the steelworks in the meantime, the steel companies have received, be it, if you want, our sister company, thyssenkrupp Steel, $2 billion euro received in terms of funding. ArcelorMittal in Germany, 1.3 billion euro in terms of funding. Salzgitter, I think, also around $1 billion in terms of funding. They all have to move now, because it's not that you get the money and then you can party for the next 10 years. You need to now deliver. And this is why you have seen, for example, that thyssenkrupp Steel, they have now gone out with a tender of 150,000 tons of hydrogen every year. These are now the biggest off-taker in the whole world right now. But this is what really is now also driving the development of those projects a lot, and we will see more of that going forward. So I'm very confident that within the next months, many of those projects actually that are currently still a little bit hesitating will move quickly now.
As we are running out of time, I see 2 more raised hands. Maybe you go first, and then over here the last question. Thank you.
Hi, I don't think we're on. Chris Lennon from UBS, sorry. Can I just ask 2 quick questions? Following up on the commentary about the backlog and the potential pipeline evolution of the sort of 19 gigawatts, how much do you see now that are in the US or Europe that are sort of waiting for clarity on subsidies or auction schemes, maybe the 45V tax credits, if there's any sort of number you could put to that? And then the second question was looking at De Nora results on Monday and commentary about the price pressure you're seeing maybe in the Chinese market, potentially on chlor-alkali, and whether or not there's any product innovation going on your side to help defend market share rather than potentially on price. So any commentary there would be really helpful. Thank you.
So I think we've also provided in our last quarterly call a breakdown of those 19 gigawatts in terms of where they would be located. I have to say I don't know that by heart anymore actually how that was, but I think it was a little bit. One third Europe, 1/3 of that actually would be in the US, and the rest is rest of world if you want. So that's sort of the distribution of those 19 gigawatts, which is very much in line with our strategy, of course. Focusing on those 2 areas first. It's not by chance, because we are certainly selecting that pipeline, so we are filtering down to those projects that then at the end basically are summing up to those 19 gigawatts, and that's certainly how we have also selected them.
The other question was, sorry?
China price pressure. Chinese price pressure on chlor-alkali potentially, talking about the electrode business.
On chlor-alkali, actually, we are doing super well in China, both nucera and Nora. We have very, very significant market shares over there. We are not fight on price in China in chlor-alkali. We actually deliver such a high quality and reliability of what we give that the customers understood since a while that the value that we give is not comparable to anybody else. So we keep going in that direction. China expectations this year over the next years is even higher in terms of volumes because the installed base in chlor-alkali plants that have been built over the last years now is due for replacement, for recoating, for services. So both companies are very, very active over there, and I would say with impressive increase in numbers. So we don't fear at all the price pressure in China on that.
And by the way, you know, since this is also a repeating discussion actually that we hear a lot, you know, are you afraid of Chinese competition? That's the answer. In the short term, there might be an impact, yeah, and we will see them actually also making inroads in different geographies of the world. In the long term, we have a very good answer to that, and we were able to prove that if you are able to deliver quality, if you are able to deliver reliability, actually, that finally counts a lot. So we are not very much afraid of what's going on in China right now. Of course, there will be a learning curve at our customer sites, but finally, if we stick to what we are good at, I'm perfectly sure that that will actually help us to maintain a very significant market share also in the alkaline water area.
Last question over.
Thank you. Sebastian Plescher from Shareholder Value. One question regarding your supply chain as well and your own IP. How do you decide what you do in-house, like the coating, or what you're buying from suppliers? For example, I read that, for example, the membrane is, I think, bought by Agfa, and it seems that this is a critical component for you. Why you don't do that in-house and buy it from suppliers? And any thoughts on that? How you change that, perhaps also with the second generation? Then do you want to do more in-house then?
I mean, first of all, Agfa is of course one of our suppliers, not the only one, and that's on purpose like that, as you can imagine. But yes, of course, you know, I mean, the decision what we're gonna do in terms of outsourcing and what we're gonna do on our own is a intensive discussion actually in this part of our strategy. We believe we also need to have our hands around you know, those performance elements of our systems, which we need to have full control over. And a diaphragm or membrane is certainly one of those elements that could play a decisive role going forward. So as such, of course, we are investigating actually how we wanna deal with that going forward. Agfa is not the only one in the market. There are other developments in the market. There are even new developments when it comes to different membranes rather than diaphragms. I mean, Fulvio can talk for hours about that. But of course, we are trying to get our hands around those particular performance components and processes where we believe if we drive them, actually, we can create more value than if you get that to the outer world.
So now really the last question.
Thanks a lot. Stefano Gambrini, Equita SIM. My question is regarding the efficiency that we can expect in 10 years. If you can elaborate a little bit, what is the amount of efficiency, 10%, 20, 30% in the production cost, and where are mainly located? What I mean is, it is more something relating to the cells and so more in the hands of the Nora, or something more related to design of the electrolyzers. And if you can give us some examples, I don't know, you said digitalization or the use of laser. What are the advantages and when we can see these advantages in order that we can say to defend to the competition also in the long term? The second question regarding the gigafactory in Italy. Could we also have some step up in terms of efficiencies over there? And if you can elaborate a little bit about the new perspective of your Falcon product. Many thanks.
So I leave the Italian facility to hear my Italian friend here. But for the first questions, where do we see cost improvement potentials and how are we driving that? First of all, don't forget we are coming from a very mature technology already. So, you know, our starting point is way lower than with many others, which is a competitive advantage already that we're playing out in the market. But of course, we still see that there is improvement potential when it comes to cost. We believe with the existing setup and technology, we might be in the range of 10% cost reduction, which is still achievable, and it will be across the board. Coatings need to contribute as well as actually also you can imagine by further automation and serial production, we will be, and with the scaling up, we will be able to leverage procurement volumes. If you buy the same parts again and again and again, in large volumes, of course, you can increase the pressure on the suppliers. You can lower the prices, and you can actually with that also decrease the cost. In addition to that, with serial manufacturing, you're typically also able to increase the productivity, and also that is basically ending up in lower costs. All of that together is something we can do only to a certain extent with the existing design, and that is actually also one reason why we decided to develop something in a different design, which is the 2.0 AWE solution, where this will be way more geared towards serial manufacturing, towards automation, to also further come down in terms of costs by further leveraging those kind of initiatives. Italian factory.
No, again, let's say the Gigafactory was designed to actually import all the newest technologies and all the automation that we've been developing in the other factories. And I don't think we can set a limit to the amount of efficiency that you can improve, because simply we have overcome all the previous target so many times that it would have been unfair to say that there is a limit. There is, I can say that in our process nowadays, there is of course no scrap in the noble metal usage. There is very little, let's say, on the metal parts, and like correctly said by Werner, if we can get rid of some design hurdles, we actually may improve that. The Gigafactory will actually produce some elements for nucera, and so over there we are already bringing what you will see later in the factory tour. And as far, let's say, the other components of the Gigafactory, as you were asking, we are bringing in just, let's say, to compete mainly on the PEM market, so small electrolyzer, our new model, and yeah, it is a totally different scale. It's much smaller, and it is a kind of self-standing unit for what we call containerized solution.
Well, thank you so much for your questions and the interest. Thank you so much for joining remotely as well. Thank you so much for being here, the four of you. And now, well, let's take theory into practice. Robert, can I ask you up to explain the tour to us?
Hello. If you could put up the slide with the tours. Yeah. Oh, it's a bit small. I think it's probably better seen. Just to repeat, please, the core object is to show our technologies to you, but safely, please. So please, I remind you again, no touching. What is very critical, in my view, is the walking to the area, because we have a transport area here. We will try to stop all transport short the time, but please stick together. In order to rationalize and to debottleneck the movement of people, you have received on entry into the premises a card with a color on it. Could you please find that at the moment? Yeah. This color will then assign you to a group. Each group will have a leader and a shepherd at the back to make sure you do not get lost. The green tour, I hope you find your tickets. The green tour, I will lead. So please join me on the after you've received your PSE in the corner, and also your microphones that are also color-coded. The easiest group is group number 3, which I think, if I'm not colorblind, are purple. Please remain seated or remain back a bit, because you're actually going to the virtual reality tour first. So tour number 3, please stay here. Tour number 2 will be done and led by Chris, who, please put up your hand in the corner. So please, once you've received your microphones and glasses, go to Chris. And tour number 4 will be led by Marcel. Ah, there you are. He's quite small, so that's... so Marcel and Kai will lead the other tour, the tour number 3 to the virtual reality. So again, please think of your safety. You can ask questions because of the microphones by going through, and then we will come back here on a tour. So the layout of the factory is, you see where you see number 2 is basically the mechanical manufacturing, the middle section is coating, the bottom left-hand corner is the service section, and number 4 is for the gas diffusion electrodes. So we will be split up. So please remain with your group and stay safe. And we see ourselves back here in 1 hour. Okay.
One last thing. I would just like to invite you to store your luggage here on the left, because during the tour we will be setting up for the light lunch. So just not leave anything on the chairs.
And just to avoid embarrassment later, no photographs, please.
Thank you very much.
When 3 global experts joined forces and combined their competence, they became a world leader in chlor-alkali electrolysis, producing raw materials for industrial progress. Our unique expertise in developing, constructing, operating, maintaining, and advancing high-efficiency electrolysis plants has allowed us to enter a new era. We've become thyssenkrupp nucera, a leading global electrolysis technology provider. Today, we build on our heritage, our expertise, and our strong track record to scale up alkaline water electrolysis and address one of the biggest challenges of our time: to reduce CO2 on a large scale. By enabling industry transformation with green hydrogen production at commercial scale. Based on our core competence, we have developed 2 strong portfolio elements that create synergies: growing, learning, and constantly improving our leading technologies to strive for the best. The future offers an opportunity to shape something that matters. Innovative solutions for industrial progress and green value chains.
Our electrodes will play a primary role in delivering sustainable solutions for the environment in the next years. It is a must to have resistant and efficient electrodes. This is where the Nora's knowledge and experience makes a difference.
Wherever you look for great innovation in smartphones, PCs, tablets, and other electronic products, you will find De Nora's electrodes. We at De Nora are strongly focused in making our manufacturing process more sustainable. We can make differences in decarbonization.
Our electrodes for the chlorine and caustic soda industry have superior performance in terms of energy consumption, efficiency, and high product life expectancy. I am lucky to work in a company dedicated to making people feel that they are the most important resource. With its global presence, Nora promotes diversity, equity, and inclusion.
We believe our company will play a pivotal role in a future of full electrification, both direct or through green hydrogen.
It is decisive to have the proper technology for green hydrogen production. Nora is ready today, and it will be readier soon, thanks to its production capacity expansion plans.
Only recently have industry experts, academics, and government leaders come to the realization that it is just not possible to electrify everything. This is where green hydrogen comes in. And thanks to the world-class electrodes here at Nora, we are serving as the launch pad for the hydrogen revolution.
Our water technologies are defined by key innovation proven by time. One of the hardest challenges we need to face is providing cost-effective water treatment solutions to remote areas, so we can continue bringing positive changes to our world.
In our world today, many regions face increasing challenges of water scarcity. Nora delivers clean water through our robust filtration technologies, which are continuously upgraded. There's still much work to do in this field, and Nora is a fundamental player in this mission.
As an expert in this technology for 100 years, Nora has been and continues to be instrumental in making chlorine available and cost-effective in the quantities needed for water treatment. The wide variety of challenges, the wonderful people you meet, and the constant focus on human health and environmental stewardship made me realize it was one of the best, if not the best, business to be in for me. I hope you've enjoyed getting to know my colleagues and me a little more this year. Stay tuned for more Decode in 2024.
We know time is running. We need solutions ready to use on a large scale. We have to think big. Alkaline water electrolysis provides the necessary big scale, all ready today, is reliable and safe to run. We use and advance this proven technology to shape a new energy age. Long-standing know-how and expertise provide high efficiency and proven quality, sustainability with highly durable and long life cells, full service solutions from a single source, and the passion to improve and innovate. We combine about 300 high efficiency cells into one powerful unit. Scalar, a standardized modular solution that can be scaled up row by row. We ramp up our capacity day by day, together with partners, as a driving force. We think, we act, and we walk ahead. Who we are? thyssenkrupp, nucera. We shape the new era.